In the present discussion, we have derived Legendre differential equation. For that, we should start our journey with dv dx of 1 minus x square dy by dx plus n into n plus 1 into y equal to 0. This is the starting equation. Now we have to differentiate this factor. This is u, this is v. There is 1 minus x square d by dx of dy by dx is d square y divided by dx square. Then d by dx of 1 minus x square is minus 2x. Write down this term dy by dx plus n into n plus 1 to y equal to 0. This is equation 2. Now I have to write the solution for this equation. The solution is of the form y equal to x power k a0 plus a1 into x power minus 1 plus a2 into x power minus 2. Then ar x power minus r. This is modified as summation r equal to 0 to infinity a suffix r x power k minus r. So this is the solution for this equation 2. Here put r equal to 0, we can get the first term a0 into x power k. If you put r equal to 1, we can get a1 x power k minus 1, the second term. In this way we can get all the terms. So y equal to summation over r equal to 0 to infinity ar x power k minus r could be the solution for this equation 2. Now we have to find out dy by dx and d square by dx square. The value of dy by dx equal to a suffix r k minus r x power k minus r minus 1. This is the value of dy by dx. Then d square y by dx square equal to ar k minus r minus 1 into x power k minus r minus 2. This is the value of d square y by dx square. Now we have to substitute these two values in equation 2. Now see the equation 4. Just we have substituted the values of d square by dx square, dy by dx and y. 1 minus x square in equation 2, substitute the value of d square by dx square. Write down this 1 minus x square as such. D square by dx square is a suffix r k minus r minus 1 into x power k minus r minus 2. Then minus 2x into dy by dx. The value of dy by dx is this much. ar k minus r x power k minus r minus 1 plus n into n plus 1. The value of y is ar x power k minus r. Entire is equal to 0. Now we have to simplify this. This is modified as, see, 1 into this term. It is k minus r minus 1 x power k minus r minus 2. 1 into these terms. We have to take out ar as a common term. Then minus x square into k minus r k minus r minus 1 x power k minus r minus 2, then minus 2x into k minus r x power k minus r minus 1 plus n into n plus 1 x power k minus r, entire is multiplied by a suffix r, that is equal to 0. Now we have to modify this further. This is k minus r, k minus r minus 1 x power k minus r minus 2, see, minus k minus r k minus r minus 1 x power k minus r, because this is x square. X square into x power k minus r minus 2 is x power k minus r, minus 2 into k minus r x power k minus r. This is actually x power 1. X power 1 into x power k minus r minus 1 is x power k minus r, plus n into n plus 1 x power k minus r, entire is multiplied by a suffix r equal to 0. This is equation number 5. Now we have to modify equation 5. This is, write on this term k minus r, then k minus r minus 1 x power k minus r minus 2. Then take this minus of k minus r as a common term. Now open a bracket. This is k minus r minus 1. This is minus 2 into k minus r, but we have taken out minus k minus r as a common term. So we have write plus 2 here. This is multiplied by x power k minus r. Just we have combined these two terms. We have taken this minus k minus r outside. So k minus r minus 1 plus 2, because we have taken out minus k minus r as a common term. Entire is multiplied by x power k minus r. Just we have combined these two terms. Plus n into n plus 1 x power k minus r, entire is multiplied by ar is equal to 0. This is modified as k minus r into k minus r minus 1 x power k minus r minus 2 minus k minus r into k minus r minus 1 plus 2, that is k minus r plus 1, minus 1 plus 2 plus 1 x power k minus r plus n into n plus 1 x power k minus r, entire is multiplied by a suffix r equal to 0. So this is equation 6. In equation 6, put r equal to 0 and equate the coefficient of x power k to 0. In equation 6, if you put r equal to 0, we may get k into k minus 1 x power k minus 2. See here, k into k minus 1 x power k minus 2 minus k into k plus 1 x power k plus n into n plus 1 x power k, entire is multiplied by a0 equal to 0. If we put r equal to 0, we can get this equation. In this equation, we have to equate the coefficient of x power k to 0. Say, this is the term which has the coefficient of x power k. This coefficient should equal 0. If r equal to 0, if r equal to 0, we can get this equation. This equation 6 is modified in this form. If r equal to 0, equation 6 takes the form of this much. This is 7. Form of equation 7. On equating the quotient of x power k to 0, we can get, see this, n into n plus 1 minus k into k plus 1. Entire is multiplied by a0 equal to 0. Coefficient of x power k equal to 0. Therefore, n into n plus 1, this term, minus k into k plus 1. Entire is multiplied by a0 equal to 0. This is n square plus n minus k square minus k into a0 equal to 0. Here a0 not equal to 0. The quantity a0 not equal to 0. Therefore, n square plus n minus k square minus k equal to 0. This is n square minus k square plus n minus k equal to 0. This is n plus k into n minus k. N square minus k square is n plus k into n minus k plus n minus k equal to 0. Take n minus k outside. This is n plus k plus 1 equal to 0. From this equation, say this is equation 8. From equation 8, we can write n is equal to k. That means k equal to n. This is one option. Because from equation 8, it is clear that either n minus k equal to 0 or n plus k plus 1 is equal to 0. If n minus k equal to 0, then the value of k equal to n. This is one option. And another one option is k equal to minus of n plus 1. This is second option. From this equation 8, k equal to n. Otherwise, if n plus k plus 1 is equal to 0, then k equal to minus n minus 1, that is minus of n plus 1. These are all the two possibilities of k. Now, put r equal to 1 and equate the coefficient of x power k minus 1 to 0 in equation 6. Put r equal to 1, put r equal to 1 in equation 6. We get k minus 1, k minus 2, x power k minus 3. If you put r equal to 1, k minus 3, k minus 1, k, r equal to 1 means k minus 1 plus 1. So, this is k, x power k minus 1 plus n into n plus 1 x power k minus 1. Entire is multiplied by a1 is equal to 0. On equating the coefficient of x power k minus 1 to 0. So here n into n plus 1, we have to equate the coefficient of x power k minus 1 to 0. N into n plus 1 minus k into k minus 1. The entire is multiplied by a1 equal to 0. See that you know that k equal to n. N square plus n minus n into n minus 1. Entire is multiplied by a1 is equal to 0. This is n square plus n minus n square minus n. See, n square plus n minus n square plus n into a1 equal to 0. N square minus n square cancelled out. N plus n is 2n. So this is modified as 2n into a1 equal to 0. 2n into a1 equal to 0. Therefore, a1 equal to 0. 2n not equal to 0. Therefore, a1 is equal to 0. So this is equation 9. Now we have to modify this equation 6 into a new form. K minus r into k minus r minus 1 x power k minus r minus 2 into a suffix r. Just we have multiplied this. Plus n into n plus 1. See this. Write down this term first. Minus k minus r into k minus r plus 1. Entire is multiplied by x power k minus r into ar is equal to 0. Say this is equation number 10. We have written this term as such: k minus r minus 1 x power k minus r minus 2 into this ar. Then rearrange this term, positive term first. N into n plus 1 minus k minus r into k minus r plus 1. Entire is multiplied by x power k minus r into this ar equal to 0. Now we have to express all the terms in terms of x power k minus r minus 2. Here x power k minus r is present. We have to express this in terms of x power k minus r minus 2. So in this second term here, put r equal to r plus 2. There is no more change in the first term, but in the second term, instead of r, we have to write r plus 2. Now this is modified as k minus r minus 1 x power k minus r minus 2 into ar. First term is written as such. Now come to the second term. N into n plus 1 minus k minus r. Instead of r you have to write r minus 2. So instead of r you have to write r plus 2. So k minus r is k minus r minus 2 into k minus r minus 2 plus 1. Instead of r you have to write r plus 2. Minus r means minus r minus 2 plus 1. This is multiplied by x power k minus r minus 2 into a r plus 2. Instead of r you have to write r plus 2. Entire is equal to 0. This is equation 11. On equating the quotient of x power k minus r minus 2 to 0. Say we have to equate the quotient of x power k minus r minus 2 to 0. We get k minus r into k minus r minus 1 into ar plus n into n plus 1 minus k minus r minus 2. This term is modified as k minus r minus 1 because minus 2 plus 1 minus 1. This is multiplied by a r plus 2 equal to 0. This is equation number 12. Just we have to equate the quotient of x power k minus r minus 2. K minus r, k minus r minus 1 into this ar plus n into n plus 1 minus k minus r minus 2. Here k minus r minus 2 plus 1 is k minus r minus 1. Entire is multiplied by a suffix r plus 2 equal to 0. From this, the value of a r plus 2 is equal to minus k minus r into k minus r minus 1 into ar divided by this term n into n plus 1 minus k minus r minus 2 into k minus r minus 1. Then this is modified as a r plus 2 which is equal to k minus r into k minus r minus 1 into ar divided by, write this term first, k minus r minus 2 into k minus r minus 1 minus of n into n plus 1. This negative sign is changed in this way. Multiply with the help of a negative sign, this term is modified. K minus r minus 2 into k minus r minus 1 minus of this term. So this is changed as positive. This is the value of ar plus 2. Say this is equation number 13. Now we have to modify this denominator. Now the denominator should be modified in a new form. Take this denominator k minus r minus 2 into k minus r minus 1 minus n into n plus 1 which is equal to k square, k into k square minus kr minus k, then minus once again this r into k, kr minus r into minus r plus r square minus r into this minus 1 plus r, then minus 2k plus 2r plus 2 minus n square minus n. Just k into k square minus kr minus k, then minus r into k minus kr minus r into minus r plus r square minus r into minus 1 plus r, then minus 2 into k minus 2k minus 2 into minus r plus 2r minus 2 into minus 1 plus 2 minus n into n minus n square minus n into plus 1 minus n. This is equal to k square plus r square minus 2kr. Just we have combined the terms. See this k square r square is minus kr is minus kr, so minus 2kr. Then combine these two terms by the way of taking minus outside. If I take minus outside, k minus r. Then combine these two terms. Take minus 2 outside, once again k minus r. If we take minus 2 outside, we can get k minus r. Then plus 2 minus n square minus n. Then this is equal to, see this is our k minus r whole square. A minus b whole square is a square plus b square minus 2ab. K minus r whole square is k square plus r square minus 2kr. Then take this minus k minus r as a common term. Here this is 1, this is plus 2. 2 plus 1. Just if I take minus k minus r, we can get 2. Here we have taken out minus of k minus r, here plus 1 is present, so 2 plus 1. This 2, this 1. Plus 2, take minus sign outside, minus, if you take minus sign outside, n square plus n minus 2. See here, just we have taken out minus n outside, n square plus n minus 2. Now you have to do small modification. K minus r whole square minus of k minus r, this 2 plus n, 2 plus 1 minus of n square plus n minus 2 should be modified in order to factorize them. For that, this term should be modified as n plus 2 minus n plus 1. See here, n minus n, 0. I have introduced one n and I have subtracted the same n. N plus 2 minus n plus 1. Minus of, here n square, this n is modified as 2n minus n minus 2. See here, n square, n, instead of n I have written 2n minus n. 2n minus n is n minus 2. Now you have to align the terms. This is modified as, this is equal to k minus r whole square minus k minus r. This is n plus 2, take this minus n commonly outside. This is n minus 1. See here, n plus 2, take out this minus sign outside as a common term, n minus 1. If you multiply, we can get minus n plus 1, the same term. Minus, here, take n outside. This is n plus 2 Then take minus 1 outside. This is n plus 2. Take n outside. N into n plus 2. Just we have combined these two terms. Take n outside, n plus 2. Here, take the minus n outside. That means minus 1 is n plus 2. Now we have to modify this further. From this we can write k minus r whole square, then minus of this k minus r, n plus 2 minus n minus 1 minus of, take this n plus 2 as a common term. If I take n plus 2 as a common term, this is multiplied by n minus 1. Just so take this n plus 2 outside, n plus 2 into n minus 1. Now take this k minus r outside. If I take 1 k minus r, here you can have k minus r minus of n plus 2 minus n minus 1, or we will give a little bit modification for this term. Now we may allow this k minus r to operate on the terms k minus r whole square minus of k minus r into n plus 2, then minus into minus plus, plus k minus r into n minus 1, then minus of n plus 2 into n minus 1. See, mere multiplication, nothing new to interpret. Just we have operated the terms internally. Now the above equation is further modified as k minus r whole square minus k minus r into n plus 2. Here take out this n minus 1 outside. Then k minus r minus n plus 2. Just we have combined these two terms. K minus r whole square minus k minus r into n plus 2 plus take this n minus 1 outside. So this k minus r minus n plus 2. Now take this k minus r outside. This is equal to k minus r into k minus r minus n plus 2. Here I have taken out 1 k minus r, so k minus r. If I take this k minus r, the remaining term is minus n plus 2. Here n minus 1 into k minus r minus n plus 2. If you take this k minus r outside, once again we can get, see here k minus r minus n plus 2, here also k minus r n plus 2. Now we may take this k minus r minus n plus 2 as a common term. From these two we may combine. If you take this term, this is equal to k minus r minus n plus 2 outside. Say this is one term. K minus r minus n plus 2 outside. Then rest of the terms are k minus r plus n minus 1. So just we have taken this k minus r minus n plus 2 outside, k minus r plus n minus 1. So instead of this k minus r minus 2 into k minus r minus 1 minus n into n plus 1, we have write this term k minus r minus n plus 2 into k minus r plus n minus 1. Now a r plus 2 which is equal to k minus r into k minus r minus 1 ar divided by k minus r minus n plus 2 into k minus r plus n minus 1. So this is equation number 14. This is our recursion relation. A r plus 2 which is equal to k minus r into k minus r minus 1 into ar divided by k minus r minus n plus 2 into k minus r plus n minus 1.